these wavelengths are there, it will get absorbed. Okay, so here how much is getting emitted, it is being recorded.
Okay.
Okay, so you can see this is the where the plasma will be ignited.
Okay. That's the tube.
Yeah, this is the tube and this is the point where so through this tube the plasma will get ignited.
Okay.
Okay, so this chamber will be always closed since it is not in working condition. So I'm just showing it out. So this is the actual torch.
Okay.
Okay,
This is the burner.
This is the plasma
This is
generator.
the torch. Okay, so you can see here the gas will be connected and this is the heater. So through here the plasma will get generated. Okay, so what happens is through the torch we are making the sample to be in.
Sample to be?
Samples will be taken in, okay, through the nebulizer tip. So it will be vapors. Okay, those which is mixed with the argon. Okay, inert gas which is mixed with the argon. So through those vapors it will get come through the chamber and here it will get emitted. It will absorb the energy like it is vaporizing. So you are doing a destruction work.
The input is this corner. Here it is inputted.
Yeah.
So that the stream passes through the tube and the reaction is happening inside the tube.
Yeah, inside the tube. So if any, what you can say, other particles are there, it will get deposited on this tube.
Okay.
So you can see there is some foggy.
Yes.
So since we had kept it for cleaning, okay, else it will be like crystal clear.
Okay.
So if any other deposition like carbon more is there and if it is not filtered properly and if other elements are there, it will get burned and it will get adhered to the surface.
So how do we clean this?
So we are going to keep it in aqua regia.
Aqua regia. Okay.
Overnight of soaking in aqua regia. It will help to remove all the scaled portions and it
Okay.
will clean.
Okay. This is called the plasma tube and the nebulizer tip.
And this is called the torch.
Torch.
So here you can see there is a radial torch. Okay, this is the axial torch. What I said, open it out.
Yeah.
So this is the radial torch.
Okay.
Okay, so
Radial torch in the sense?
see whatever the emission it is getting absorbed. So either it is taken in the line of the emission of the flame or in a perpendicular to the emission of the flame.
Okay. So those are sensors which detect the light.
Yes. Okay, so this will be connected to the nebulizer chamber. So this is where the samples will be taken in and it will make a spray and it will be connected to the argon gas. So it will vaporizes into smaller water droplets. So those water droplets will be taken in through this canal and the plasma it will be taken in. So during the plasma, the reaction it takes with the ionization. So all the water molecules will get evaporated. Only the ions will be there. So at that certain element absorbs the energy and it will emit certain wavelength. So that wavelength it is getting determined. So all the setups are there inside this box. Okay. So there will be filters and the particular wavelength it will be getting identified and later it will say like okay this is
the element.
for this wavelength this element has been identified.
Okay.
Okay. So this is regarding the instrument. So this is a auto sampler. So we can set up the auto sampler where the sample intake will be easy.
Okay.
Or we can also go for the
The
manual
arms
sampling.
move one by one like this.
Yes. So whichever the trays if we identify it out.
Okay.
So during that it will automatically come, dip it, take the sample in. After the analysis is over, then it will go. This is the flush. So it will clean itself. So it will be connected to 0.2 normal nitric acid. This will be prepared. So
okay.
every time if it touches each sample, it has to go flush out and then it will cleanse on its own.
Okay.
Else we have to clean it, wipe it and again we have to put it in the sample. So there should not be any cross contamination. If
Okay.
cross contaminate, in that case it will get mixed with the values.
Yes.
So finally, whatever the values you are getting, it will be varied.
So after every sample, a new fresh batch of 0.2 normal in HNO3 is taken in. Again, it is fired. Am I right?
Yes.
And then again the next sample is taken.
Yes.
So fired as in?
So for every 2 samples taken, one is the original sample, one is for this cleaning purpose.
One will be cleaning purpose, 3 will be the original sample.
Or for every 4, 1. 4 is to 1.
So it depends on what ratios you have given. You have given for single sample determination or double duplication is there or triplicates.
Okay.
So usually we go for triplicates. Or
So,
sometimes we will go for only duplicates. So if duplicates are given, then 2 samples will taken, and after flushing out, then it has to clean entire system because the samples will be there. So it will be taking in uptake, and later through the nebulizer chamber, the spray it will be entered into the ionizing chamber. So all the things will get normal. So 0.2 normalization of 3, and after those things are there, then it will come to a fresh batch and it will uptake
so
the
that
sample.
is already like you have to simply arrange it in such a way.
Yeah.
Else it will take care.
So the
So,
numbers we had.
For
raised
example,
here.
one sample is taken,
Hmm.
it gets into the torch,
Yes.
it gets done, then HNO3.
See, HNO3 will be fed continuously into this.
Okay.
So this is the home pot. So
This is the?
this is the home.
Home.
Okay. So it will always, the dipstick will be there in the home only. So these are the positions where we are keeping the standard solutions.
Okay.
So we are preparing for the linearity of the samples
Yes.
like 0.5 ppm, 10 ppm, 1 ppm, 10 ppm, 20 ppm, 30 ppm, 50 ppm, 100 ppm. So that we will get a linearity in the curve. So after the standard samples has been get the linearity. So with respect to the standard samples linearity, whatever the samples it is taking in, whatever the wavelength it is going to identify, what concentration it is going to get it, through that concentration it is going to interpolate and it will give us the value.
Okay.
Okay, so without the standards input, we won't get the what is the actual value. So these are the basic
So
procedures.
standard blanks will also be of different concentrations.
Yes.
Okay.
So we are going to create a blank also. See, this is the actual torch. So after the running, so this is how it will get greased.
Want to check?
No, do not touch it. Again, you have to go and wash it yourself. Okay, so you'd see in that very clean torch. Okay, so this is how after the analysis is completed, the torch looks like.
Okay.
But where is the spark coming from? Like, is there a
There's a plasma in there, right? With the tip on the other side. This gets joined.
See, it is not going to catch like a fire, what you are observing. As you've seen in AES, it's going to catch a fire.
Catch a flame,
But here what happens is, since it's an inert material, at certain heating temperature, there is a coil. Through that, the ignition will happen. So that is why it called as a plasma induction. Okay, so it will be more than 3000 Kelvin. Okay, so that much of energy it is going to liberate. If you are looking into there, it will be in
that is
terms
the
of
flame.
yeah, the
800
flame. It
degrees
will,
or something.
yeah, that is the temperature what we are seeing. So here, that is why there will be a coolant. Okay, this is the coolant.
Okay.
It will be always switched on during the running.
What is the coolant of?
Water and water coolant. It will be mixed.
Water.
Water only.
Okay.
Okay, so this is the chiller or cooler. So through this, the water will get entered into the chamber. Okay, so this is the water pump. So this will make.
That's
the
a
water-
pump?
Yes.
What type of pump is it?
Because those are all of least importance for us. What type of pumps? Those are all pumps for the technicians who will be coming with. And since we are not having the authorization, like we can remove it and we can add it. So those are their scope.
This radial one,
Hmm.
where does it join it from?
See,
It just goes and sits on top of
there
it.
is a sensor.
Okay.
Okay. So whatever the
So-
samples will be fed in.
It is curved?
Yeah, it is covered.
Okay. So it exactly lines up and fits into
Yeah. So the sensor will be taken from here.
it. Okay.
Okay. So here the plasma will be burning.
Okay.
So during the burning, whatever the samples will be intake, at this position it will go for the ionization.
Okay.
So once the ionization happens, so the axial detection will be there, and this is the radial detection.
Okay.
Okay, few samples like few elements will be readily detected. Okay, it depends on the instrument. It is not like it is fixed for all the instrument. Based on the manufacturer's things, it will be defined. Okay, few elements can be determined radially. So that is why whenever we are running, we don't know which element will be coming under radial of that particular wavelength, which will be coming under the axial. So we can feed the highest concentration and we can generate the auto peak. So if you are taking like 50 ppm is the highest concentration for the calibration you are taking the standard. So you are going to feed the first sample and you are going to look in what are all the determination is going on. So automatically it will assign like, okay, for these elements are getting determined in radially in very good condition, these elements are getting determined in the axial. Okay, so 90% all the elements are determined in the axial mode only. So few elements where certain traces are there, in that cases we are going for the radial. Okay, so these are based on here, and whatever we are working on. Can you see the process? I can get a book here.
Q-Tech.
This is the software,
Thermoscientific.
Thermoscientific Q-Tech.
Okay.
For this model, Q-Tech will be used.
So there's a licensing for it, or it comes with the machine?
It comes with the machine. So this is how the dashboard looks like. Take a chair. So if the plasma is ignited, then this will be in green. So since we are not switched on, that is why it is in the grey color, and it will say connected. It is connected, but still it is showing red means since we are not switched it on. If we switch it on, then the blue light will be there. Okay, so rack unknown it is going to show, and here it is going. These are all the fixed energies. RF power, purge flow, normal. We can go for normal, high, triple. So whenever we are keeping for purging, the main purpose of purging is if there is any oxygen molecules in the chamber that has to be evacuated.
Okay.
Because during ionization, so it will leads for the disruptions in the analysis.
Okay.
So it should be carried out in an inert environment.
Okay.
So that is why we said like we are going to purge for 2 hours or 1 hour in
Okay.
a normal or trickle mode. Okay, so once the 2
So
hours are
how much gas gets consumed in 1 or 2 hours?
almost half a cylinder it will get consumed.
Half a cylinder. So what would be the cost of it?
One cylinder refilling it will take around 7,000 rupees.
7,000 rupees. So totally if we run
So
an experiment,
if you are running, that is why
around
if you are
50,
running
60
an
samples?
experiment, no, till 100 samples can be run, 100 to 120 samples
okay.
with 2 cylinders.
Okay. 2 cylinders. 1.5 cylinder for the purging and around 1.5 cylinder
No,
for
both the cylinders will be connected and it will be simultaneously kept on. So that is why we are having the gas level monitor.
Okay.
Okay, you can see the channel 1, channel 2, channel 3 and channel
Yes.
4. So we are having the 4 cylinders.
Yes.
Okay, left side 2 cylinders are connected, right side 2 cylinders will be there. I will
Okay.
take you to the gas chamber so that you
Yes.
can see. However, it will be locked.
Okay.
Through the jali you can see
Okay.
which are the cylinders and all. Okay, once we switch it on over there, we will get the light on. Okay, once this is a safety alarm. So once the pressure drops, in that case it will give a beep. And also we are going to monitor through the gauges. Okay, so this is the gauge. It should be above 8.
Should be around
Okay, 8 or above 8. So we had already set the walls in such a way, you just open it out, it will come and stand 8 or the first knob value. Okay, once the first alarm buzzes, in that case it has dropped here 6 to 8. In the range of 6 to 8, the first alarm will buzz. Then second alarm will buzz means suddenly it will fall stop.
Okay.
So after the first alarm buzz, we will go reconnect with the new cylinders and we will keep it will be in the purging mode. So during the purging mode, it is not going to consume much of the gases.
Gases.
During flame is when ignited, in that case it will consume a lot of gases. Okay.
Now, how is this different from AES? Like, which is more accurate or which is more preferred?
See,
because there they told only 14 elements. According to what element you want to see, the light, the lamp, they can choose and do.
See, atomic absorption spectroscopy is a single element identifier.
Yes.
Okay, so this is a multi-element.
Multi-element, okay.
Okay, so when come to precision, even in a good precision can be taken in AES. So there are different models. So even hydrogens also we can make, means mercury also we can determine, arsenic also we can determine. What model we are having, here we can't go for that hydrant generation. Okay, means there is an additional attachment which will be kept, and hydrant has to be generated, and through that it has to fed into the system,
Yeah.
and it is going to identify. So there are AES, like 6 varieties of AES.
Oh, okay.
Okay, so once you go even up to PPB level, AES can work. Okay, what we are having here up to PPM level, we are working. So once you come to ICP-OES, it will come up to PPB level.
So ICP-OES is more precise.
There is ICP-MS also, and also
Mass
there is
spectroscopy.
mass spectrometry. There also high resolution mass spectrometry is there.
Where is the machine?
So we are not owning the machine. In Manipal, you can see in natural sciences, Manipal
Natural
School of
Sciences.
Natural Sciences. So those people are having ICP-MS. That is from, I don't remember the name, company name, not from Thermo Scientific.
Okay.
Okay, so there you can go up to PPT level.
PP?
T. Trillions.
Wow.
Okay, so there, if you are going for especially the medicals, drugs and all, so you are going to prepare the samples in 0.1 grams
Yes.
or 0.01 grams.
Yes.
So those samples will be fed into the HR ICP-MS.
Okay.
Okay.
HR
ICP-MS. Okay, so that you will be having, like if you are having the powder also, through the powder it can identify. So here only liquids will be fed in.
Okay.
You are not going to feed the solid samples.
Okay.
So once you go to the higher end of the machines, you can have in the small fine particles also can be fed in. Okay, as we are having in organic matter.
Okay.
Organic matter determination. What is that instrument? Last time we got the
TOC.
TOC. Total organic carbon.
Total organic
So
carbon.
there we can go with liquid also and solids also.
No,
Okay.
like say I have a sample, unknown sample of some liquid. Should I prefer AES first or ICP-OES first? Is there any precedence that what you
See, it depends on what
See, I don't know what
investments you
is there.
can
Huh?
do. It depends on what investments you can do.
Okay.
Okay, so if
cost
you ask
effectiveness.
me about the technical point of view, you know the element, you don't know anything. You are having certain powder. Okay, even those powder can be fed in your concrete samples also,
Okay.
like as a substitutious cementitious material.
Mm.
So in that case, what I prefer is go for SEM EDS, get the peak from there. If you are getting a higher peaks, in that case, okay, those are the higher concentration. Or you go for XRD. So it gives in percentage by weight. Okay, mass by percentage by weight. So that helps, like, okay, if higher concentration is there, you can get it there. Then next higher version comes is with XRF. Okay, so even XRF and ICP-OES both comes in the same desk, but there it works in a different principle. Okay, so and it also having its own limitation. Not every element, like 21 elements or 28 elements if you are determining, so you are not going to get every in PPB level. Few are in PPM, few are in PPB, PPB also like 10 PPB or 100 PPB, like that it will be having limitation. So after XRF, then comes with AES. Okay, there in the AES, you are going to feed it in terms of liquid. So if you are having the solids, then you have to digest it according to the different methodology, and later you are feeding it, filtering with 0.2 micrometer or 0.45 micrometer, and later you are feeding into the system. But in AES, since it is a single element determination, so what we will do, we can go for ICP-OES. Multi-element can be determined, 21 elements at a time you can go, based on what standards you are having. There are standards where you will get 14 elements, standards what you will get is 28 elements. Okay, so if
What is a 48 plate microplater, 96 plate microplater?
48?
Plate microplater or 96 plate
What is
microplater
that?
in UV spectrometer.
That is a different one. So
Okay.
that works on with the wavelength principle.
Okay.
Okay, so this also works with the wavelength principle, but here is an absorption and emission, and detector is there. So ionization. So there is no ionization is happening.
Okay.
Okay, it's just passing through the light where nothing is getting evaporated. Here everything is destructed.
Okay.
Whatever the samples it is feeding in, it will get destructed. You can't use it. But if you are going for ACM EDS, XRD, all samples stay there only. It is not a destructive one. Once you come to AS and above, then everything will be destructive.
So
Whatever-
the precision increases.
Yeah. And it also depends on the methodology I follow for
Okay.
the preparing it into a digestion method.
Okay.
There are like 6 different acids we are using. So few says like 2 acids are sufficient digestion, single acid digestion is sufficient, 3 acid digestions
So
are
this
sufficient.
standard is prepared all over the world, or the standard prepared by the owner, or the Shimadzu's or Thermo Fisher?
Yeah, what we are using is Shimadzu's
Shimadzu's
yeah,
protocol.
product.
Okay.
Okay, so the companies are going to provide us the elements.
Yeah.
So multi-standard, they will be written in it.
Okay.
So we are going to check it out over here by, since we will get it in 1000 ppm. 100 ml of 1000 ppm, it costs you around, with all tax, वगैरह 19,000 odd.
$19,000.
19,000 rupees.
19,000.
19,500.
Okay.
Okay, so whenever you are preparing, we will come with like 100 ppm and then we are reducing it to required ppm. Okay, so there only single time almost like 20 ml or 10 ml it will be fed. It depends on how much you are required for the linearity in the company. Okay, so everything comes in picture. Okay, so this is the dashboard as we looked in. Then there is the sample lab book. See, whenever we start, it starts with the parameters. So we are going to select the elements here.
Okay.
Okay, whichever the standards you are considering, those elements only you are considering.
Okay.
Okay,
So
you are
if
not
we-
considering other elements.
So if I don't know what is there at all,
You should know everything. Then only you can run. If you are not knowing anything, unknown things can't be here. So this is the ICP multi-element standard solution number 4 from Sutalco, the Sigma Aldrich company. So here it will be defined with what are all the elements, 21 elements will be defined.
Okay.
So we are taking a baseline. Through that baseline, this instrument will say, okay, these elements
These
are
elements
there.
are there
Through
in
that
this problem.
baseline, it will, if you feed an unknown sample, based on that comparison, how many counts it has taken, wavelength, that it will give you, okay, this is the concentration.
so this is that 19K solution.
This is the standard solution.
23 elements in
23
diluted
elements
nitric acid.
with 1000 ppm, 100 ml.
So these elements are present in this.
Yes.
Therefore, whenever it gets plasmid,
Yeah, whenever you feed into the standard solutions, you are going to specify whether we are feeding 0.5 ppm, you are specifying like 1 ppm,
Okay.
5 ppm, 10 ppm, up to the maximum ppm value you are taking it.
okay.
Okay, so these are the elements it is showing. So this is how I am going to select. So if I am just keeping the mouse, if I look for magnesium,
Yes.
by default it will be taking with 279.553.
Okay.
So that is the wavelength it will be
Okay.
taking. So if you look into manganese, so it is like 257.610. That
Okay.
is by, if it gives the star, that is the default one. If you
Okay.
go to zinc, 213. If you are going to look for lead, it is 220.353.
Mm.
Okay, it depends if I...
That much precision even in the wavelengths, 0.353.
It is having certain counts.
Okay.
Okay, so based on the code, since I have not switched it on, it is not going to show me. Okay. So I am going to select whether it is radial or axial here.
Okay.
So this is the acquisition parameter. So we had given like mercury, aluminium, borium, boron with radial, axial. So these are
That's a
predetermined
preset.
one. Okay, so with other lab samples book I am showing it, and for every uptake 30 seconds delay will be there. Rinsing also 30 seconds it will take, and the measurement board will be radial, and inter-element correction we are not using it out currently. The standards what you are feeding that we can list out here: 0.5 ppm, 1, 2.5, 5, 10, 25, 50, up to maximum 50 ppm, and all the elements what we selected in the analytes, so it will get listed here. Okay, then the quantification, this will be come only after the running. This is for use for the quality control. Okay, then this shows the evaluation results. So if I am going for the concentration, so this is showing with calcium it is not applicable, with the cadmium it is showing like 0.479. If I am looking for a reference standard, this is the standard one. This is the linearity curve what we are getting.
What does that signify?
See, if the linearity curve is with having R square of 0.99 or 1.
Okay, it's
So
close to be
it
close
is
to
close to the values what we can
the R
define.
value,
Yeah.
R square value.
Okay, so each elements separate. So you can see here the linearity is out of order, magnesium.
Okay.
Okay, so it is not started with 0. It's started
Yeah.
other if you look in, but still we are getting the linearity of R square 0.988.
Okay.
Okay, so this is for the standards. So 2.5, 5, 10, 25, 50, and these are all the concentrations. So it was defined for 2.5 ppm. It is determined 3.65. It is determined for 6.04. Based on this, the linearity curve.
Okay.
Okay. Then
So that is the variance that we are getting,
Yeah.
and the readings also that we have calculated.
so it depends on the counts also. Here, if you are looking for here, you can see 2.5, 6,514 counts. It has to increase. If the count is increasing, then the linearity will come.
Okay.
Okay, if you are taking like 0.5, then whatever the counts you got in 0.5, it should get double in the 1 ppm. Okay, so if you are taking for 5 ppm, you should get
5 times.
So
Okay.
then we can say whatever the standards you prepared over here in the laboratory and what this is analyzing, it is okay. Else usually we go wrong in preparation of standards. Okay.
Preparation of standards is wrong.
Yes.
But if you are buying a solution like this, I don't think that is.
Through this only, this is a 1000 ppm solution. You
Yes.
have to prepare for 0.5 ppm. That is the standards you are again re-preparing it.
Okay.
Okay, if you made a mistake, okay, the mixing, see N1V1, N2V2, C1V1, C2V2. You know the concentration and
You know the
you know the
volume.
volume. You need to pump out how much volume is required to prepare with the 0.5 ppm.
Okay.
Okay, if you made a mistake over there, then obviously here it will get reflected, and you know the cost over there and the time you are spending. And also this will be prepared with the milky water. Okay, double distilled
Milky water.
Okay, milky water with
What do you say?
Milky.
milky.
Q.
Yeah, that
Q.
is Q.
MILLIQ.
Q. That's
Yeah.
it.
Milky is a brand name, right?
Brand name.
That is the brand name.
Right.
No, we call it as a double distilled water. So if this is
Double
the-
distilled water. Okay.
This is the milky way where it becomes 18.2. It is showing with 18.2 millisiemens centimeter. Okay. So whatever it is getting filtered through 0.2 micrometer.
Okay.
There is the filter.
Okay.
Okay. Whatever the samples we are preparing, this is through this sample.
This.
Okay. So there are
This
methods.
is for water.
Yeah. So which is having 0 ions.
What is this 18.2?
There is a milliohm. That is this Siemens per
So
centimeter.
what are we going for? The least lower values.
No, 18.2 up to 15 you can consider. Below that there is no filtration is happening.
Okay.
So the effectiveness of removal of ions will be very less.
Okay.
So you usually prefer like 18.2 has to be there.
Okay.
If it is less than 18.2, then the system is not filtering properly.
Okay.
Means we have to change the filters of
Okay.
here. There are 3-4 filters that recently got changed. So you can see the filters here. These are the filters that got changed in the Mini-Q system.
Filter is over here in that column.
That is inside the blue box.
Yeah, blue box, right?
These are all ceramic.
No, this one.
This is the auto titrate.
Auto titrator.
Correct, no? This is
That
the
is okay.
What does it do?
titration.
No, wait, we'll finish our
Let us finish
ICP-OES.
this.
Then
I
we'll
have
come
not
back.
used that auto titrator. I have used the other auto titrator. Okay, so through that we are preparing the standard solution. So here we are having with 0.2 normal HNO3 is what we prepared as a sample, and 0.1 ppm multi-element ICP standard.
My battery got out.